Alright, let's look at the homework 11.10, problem number 1. Right? So we want to use the definition of a Maclaurin series to find the Maclaurin series for this given function. Alright, so let's do that. Alright, so remember that the Maclaurin series looks like this. You have f of x is going to be equal to summation, n goes from 0 to infinity, and then you have nth derivative evaluated at 0 and over n factorial x to the n. Right? So we need to find nth derivative at 0. Right? So let's do that. Right? So we try to recognize the pattern here. So first we're going to plug in 0 for f of x, and you see that the natural log of 1, which is 0. Right? And so let's take the derivative. First derivative is going to be, right, derivative of that would be, let's see, 1 plus 2x and 1 over 1 plus 2x, and multiply by 2. So multiply by 2, right? So it will look like, I'm going to write it as a 2 times 1 plus 2x quantity to the negative 1 power, right? So let's take another derivative. F double prime of x is equal to, right? So 2 is already there, so it's going to be negative 1, placed it in front, and 1 plus 2x, and subtract 1 from the power, negative 2. Multiply by derivative inside by chain rule is 2, so I'm going to put the square there, right? Then about the third derivative. Third derivative of f of x is, right, 2 squared is already there, and then you have a negative 1 is already there, right? Power rule, put the power in front, keep the same quantity inside, subtract 1 from the power, then multiply by the derivative inside chain rule. So I'm going to have to change that to, so you have another 2, so that's going to be 2 cubed. Right? Then I'm going to do one more just to make sure. So it's going to be a fourth derivative. It's going to be, right, so you have a 2 cubed is already there, so negative 1, negative 2 is already there. So power rule, negative 3 in front, 1 plus 2x, and raise it to the negative 4 power, and then multiply by derivative inside, so it's another negative 2, another positive 2. So instead of a 2 cubed, it's going to be 2 to the 4th power. Right? So you can see that this can be rewritten as, I'm going to just go ahead and write. Right? So first you have a negative 1. And how many negative 1s do we have? We have 3 of them when you have 4. So it's going to be a cubed here. Right? So you have a 2 to the 4th power. So times 2 to the 4th power. Right? Then you have, so I'm going to write it as over. Right? And 1 plus 2x to the 4th power. Right? And also we have, let's see, 1 times 2 times 3, so that's a 3 factorial. Right? So we have that. Right, now we see the pattern. So we dot dot dot. So if you take the nth derivative, then we should get, right? So the power on the negative 1 is 1 less than the number of derivatives, so it's going to be a negative 1 to the n minus 1. And then you have a 2 to the, same as the number of derivative, to the n. And then you have 3 factorial, so that's a n minus 1 factorial, right? And on the bottom, you have 1 plus 2x raised to the nth power. Alright, we got that. Alright, then I'm going to just plug in 0 for x. So nth derivative at 0 is going to be, Alright, if you plug in 0 on the bottom, so you get well, 1 to the n is just going to be 1. So you're going to get just this, negative 1 to the n minus 1 times 2 to the n times n minus 1 factorial. Right? So if you want the power series, we want to, so that guy divide by n factorial. So f of x is going to be, right, summation, right? So instead of starting from 0, we can start from 1 because f of 0 is 0. So it's 0 anyway. So we can start from 0 too, but let's start with 0 for now, to infinity, right? So the expression we got was negative 1 to the n minus 1 times 2 to the n times n minus 1 factorial. Then we're going to have to divide by n factorial. Then we have x to the n. Right? So you can cancel actually n minus 1 factorial, and n factorial is n times n minus 1 factorial, so you can just scratch out the factorial sign, right? So we have, so this is going to be so summation, right? When n equals 0, the term is 0 anyway, so they start from 1. It doesn't make any difference, right? Then you have negative 1 to the n minus 1. Then you have, we can combine 2 to the n and x to the n, write it as 2x to the n, then over n. Alright, so let's type it in. Alright, so what we got was negative 1 to the n minus 1, and then you have 2x to the n, and divide by n. Alright, so let's check the answer. Alright, I came back and it looks like we got the power series correctly. Alright, so I'm going to skip the radius of convergence because this is going to be just a ratio test, and then to find the r, and just like the example we went over in class. Alright, that's it. I hope that this was clear.